Hey everybody, welcome to another series of training videos sponsored by Technodyne. We've been working pretty hard at coming up with some way to document and pass on our experiences with our exposure to the pulp and paper industry and other industries for quite some time. If this is your first time checking out one of our videos, let me introduce myself. I'm Mickey Rowell. I work here at Technodyne. I've been here for quite a number of years. And this video, what I'd like to do is introduce you to the property that's known as porosity measurement. Air permeance is another term for it. Density is another term for it. Air resistance is another term for it. Air permeability. So there's a number of different words that have been bantered around, but they're used interchangeably. If you're brand new to the industry, you might be asking, why bother testing this particular property? Well, it's a relative sign or relative indication of what the web is actually looking like. It doesn't give you a definitive number that you can target to for a specific application, but what it will do is it'll let you know this is what kind of a blown up version of what the web might look like under high magnification. The fibers are laid down on these high-speed webs, and they are somewhat randomized, but they have all these nooks and crannies built into them, okay? That air, gas, which is fluid, can pass through, can adhere to, product can adhere to, and these numbers that these instruments generate help to give our production people an indication of, okay, is the sheet tight enough, as an example? Is the sheet open enough, as another example? They are a pretty fast means of evaluating what that characteristic is the web actually is doing as we're starting to make different changes to our process. They're influenced by a number of different other factors. One of them is refining. Another, the furnish selection. Certainly if you have a bunch of short hardwood fibers, you're going to get one particular mat layout. If you have some mixture of long fibers and short fibers, you'll get another matrix that's laid out. Calendaring. Calendaring certainly is going to change the surface. It's going to compact all these fibers, and it's going to make it maybe even a little bit harder for some air to permeate through the sheet. Now, when I talk about permeate the sheet, I'm talking about the Z direction of the sheet, from the top to the bottom, wire side to felt side, whichever you want to define it as. But somehow that sheet, in most cases, needs to breathe for different reasons. It's an indirect indicator of ink absorption or glue, helpful in gluing applications. If I'm making up a nice brochure and I've got an area that I put down some heavy ink on, and I have a double-sided brochure, I don't want that ink to wick through my matrix here to show up on the back side and then interfere with my text or another image that I have on the back side. Gluing application might be for making up envelopes. We have to have enough permeability, I guess, to allow that glue strip, when I lay that down on this sheet before I fold it all up and start to build my envelope, that glue has to wick in a small amount into my surface. I can mechanically bond to the surface with that adhesive. Now when I go and lay my second layer on top and I go through my drying process, I have a very good bond between the area that I've laid down my glue strip and the area that I'm actually gluing my strip to. All right, good strong bond. If the sheet is too open, that glue can wick into the depth of my sheet Now I have a very low level of glue, if any at all, on my surface. When I fold that over and I start to glue that surface, my sheet falls apart. Another one might be in some box board applications, so that you've got these folding box board that you're making for your toothpaste, your cosmetics, anything of that sort. Those are folded together. They lay down a glue strip, overlap one corner of it over another, and now we've got this nice strong bond. If my structure is too tight, now I get the glue, actually too much glue on my surface. I'm going to need to make some adjustments, but if I get too much glue on my surface, now I don't get that mechanical bond into the surface, and I have a weak structure there. All right. Let's say I'm building some filtration media, something like this or something like this. I need to, for sure, identify what that permeability is from before I can put this together and make it perform in the fashion that I need it to. It not only has to be able to breathe, so that in this case that my automobile can breathe, but it has to be in such a structured in such a way that I can allow air to pass through but capture the particulates that I'm trying to filter out. Cigarettes. Cigarette paper is very dependent on the permeability of the sheet. Now if I've got a cigarette that the matrix or my matrix is too tight, if I go to light my cigarette, I might be able to get it and continue to get it burn as long as I'm continuing to draw on that cigarette. But once I stop drawing on that cigarette, what might happen is that now I don't have enough air for that tobacco to burn, and it might extinguish itself. So another critical reason that we need to have that property of porosity. There's a number of, let's say, definitions that have developed over the years. We all probably recognized that we have these organizations, TAPI, we have ISO, we have SCAN, a number of these organizations put together these written procedures, written methods. So if I'm talking to a customer or a customer is talking to me and he's trying to help develop, or I'm trying to help him develop a particular product, we need to use the same language when we're talking about this particular property, any property in particular, but in the particular case when we're talking about porosity. I need to understand, okay, what method are you using? Are you using a Gurley test to get your results? Are you using a Sheffield test to get results? And if you are, what orifice diameter are you using? So there's a lot of different factors that enter into our conversation that will help us create this successful product. We have, in our industry, we have common permeability meters. We have the Gurley test, we have the Sheffield test, we have the Benson test. In some other instances that we go outside of the, let's say, the pulp and paper industry. For instance, filtration media, they have a Fraser test. Cigarette material has the Borgwald or the Coresta test. So there's a number of different tests out there. What I'd like to do is as we go further and dive deeper into some additional training videos, is to focus on the original designs of these instruments, because today you might be new to the industry, or you might be coming into a mill site that has a more modern electronic version of these tests. The more modern electronic versions of the tests isn't going to let you have a good, let's say, reference of where these results are coming from. So that's what I'd like to help do, and hope I can develop through the series of videos that we're going to create here. All of these have basically three things in common. They all have a method to clamp or sandwich a piece of paper, a sample, in between two surfaces in order to, let's say, develop the volume, the area that is under test. We have to define what that area is. We define it by having two annular rings. Some cases, the Gurley test, as an example, has a very firm, hard stainless steel for the bottom. Now it has perforations in the bottom that's going to allow, when I sandwich my paper in between here, I'm going to pressurize this side of the sheet, okay? I told you before that we have to have a pressure differential from one side to the other. But here I can pressurize this side of the sheet. As I do that, I define that area that I'm trying to test. That airflow will move through my sheet and out the bottom and out to atmosphere. So that's certainly one similarity. Everybody has to have some type of clamping mechanism, and they all design or all define in each one of these methods a specific area that they're testing their sample with. The other thing is developing a pressure means of creating a pressure differential. In some cases it's a vacuum, but in most cases it's actually creating and compressing air on one side of the sheet so that now we have a differential across that sheet, and the air will move and try to move to that lower pressure area, which is atmosphere in most cases. The third thing that is in common is that everybody has to have some type of a means of measuring this movement of air. The Sheffield test uses rotometer tubes. The Fraser test also had, early days, also had rotometer tubes. The Gurley is more self-contained in that it's a measurement of time per a unit volume of air over that fixed area. I would say that as you start to look at the particular tools that you have on hand, you may or may not have the perfect tool for your particular property or your particular grade mix, but certainly you can continue to use that and still gauge in a relative sense how that product is developing, how that web is developing. I don't know that you could say that there's a perfect method that would cover all makes and models of the products that you are making out in the field, for anything from copy paper to good brochure paper to filter paper to container board paper. So there's a wide range of permeabilities that are developed in those particular products. There isn't one unit that's probably going to be successful in covering all of them, but you could get some pretty good results and some pretty decent result information from them anyways. So as we venture into this property called porosity, again, what I'd like to do is in each one of these successive videos, dive a little bit deeper into the specifics of a particular test, whether it's the Gurley test, the Sheffield test, the Benson test, and give you some more details of how those tests are laid out, the methods that are used, the specifics about the pressure differential that's being used, the area that's being tested, and so on. So hopefully you'll come back, look at some other videos. Maybe you'll get a little bit more information about a particular device that you have in your mill, and gain some new information and build on that for future development. Alrighty? So thank you for joining, and I'll see you later. Bye.